Hello, in our last lesson, we have done the curve sketching for polynomial functions. Polynomial functions means degrees for the x value is positive or zero integers. So in this lesson, we are going to see the rational function. So we have the polynomial function divided by a polynomial function. And we are going to follow the same steps. So step 1, what we are going to find is the x and y intercept. And we want to start with y-intercept. The reason for that is it's easier to find. It's just sub in x equals 0, then f at 0 is our y-intercept. So 0 over 0 squared minus 1. We have numerator is 0, denominator is non-zero, so the whole function's value is 0. And for the x-intercept is numerator equals 0. So it means top equals 0 is x equals 0. So it means we have 0, 0 as our x-intercept. And step 2, we want to find the asymptotes. So horizontal asymptotes, vertical asymptotes, and the oblique asymptote. So horizontal asymptotes, we just need to check the degrees. The degree for numerator is 1, degree for the denominator has degree is 2. Numerator is less than the denominator's degree, so we know the horizontal asymptote is y equals 0. When x approaches infinity, the denominator is 1 over x, give you 0. So we have a horizontal asymptote, y equals 0. Then we don't have the oblique. You only could have either horizontal asymptote or oblique asymptotes. And opposite, vertical asymptotes means the denominator. Denominator equals 0. This is our vertical asymptotes. So we have x squared minus y equals 0. We could use a factoring, or you could move the 1 minus 1 to other side because you have only one variable x appear once. So if x appears only once, we can isolate it. Now we know we have the vertical asymptotes is x equals 1, negative 1, and x equals positive 1. So the next step, step 3, we want to find the derivative, the f prime equals 0 or undefined. So we call it critical points. And for the critical points, it doesn't matter the sign of the f prime. As long as f prime equals 0 or undefined, then at the x value, you have the critical points. So we need to find f prime. X equals, and this one is a quotient, so we could use a quotient rule. U divided by v equals v squared. U first come, first derivative, u prime v minus second prime. Okay, so v is x squared minus 1 squared. Then u prime x prime is 1. Copy the denominator, then take away numerator, then denominator derivative is x squared. Bring the degree to the front, degree minus 1. We have 2 and x. 2 minus 1 is 1. Okay, x to the exponent 1. Constant derivative is 0. Then we simplify it. We have x squared minus 1 minus 2x squared all over x squared minus 1 bracket squared. Collect the like terms, negative x squared minus 1 over x squared minus 1 bracket squared. Then we need to find the f prime equals 0, so numerator equals 0. We have negative x squared minus 1 equals 0. We could move the x squared, negative x squared to the other side. We have x squared equals negative 1, so no solution. because square root of a negative number is undefined. So no zeros for the critical points. And undefined will be the denominator equals 0. So x squared minus 1 bracket squared equals 0. Square root both sides, we have x squared minus 1 equals square root 0, give you 0. Then move the minus 1 to other side. Square root both sides. Don't forget you have the plus minus sign there. So x equals negative 1 and x equals positive 1. They are the critical points. And step 4. We are going to find the second derivative equals 0. But this one also we know is a vertical asymptote. It means it's not allowed. It's not in the domain, so no critical points. Because at these 2 points, the function is undefined. And step 4, the points of inflection. It means a double prime equals 0 or undefined, but in order to be the point of inflection, the f double prime need to change the sign. Otherwise, we don't call the change sign. Otherwise, we don't call it point of inflection. It's just going to be the local maximum or minimum. So f prime x equals negative x squared minus 1 or x squared minus 1 bracket square. So double prime, we could use a quotient rule again. So numerator, so u over v equals v squared u prime v minus uv prime. So v squared x squared minus 1 squared give you 4. This derivative is negative 2x times x squared minus 1 bracket squared minus bracket negative x squared minus 1 times this squared will be the derivative will be the chain rule. So bring the 2 to the front, then degree minus 1, then continue, do the derivative to the base. X squared minus 1 derivative is 2x. Then we have this second derivative, then we simplify it. So equals x squared minus 1 to the exponent 4, negative 2x. We don't want to expand it yet. We want to have common factor. We can factor it out. So minus minus, we can change all of them to positive. Then this 2 times 2 is 4x. Then x squared minus 1 to the exponent 1. Then we have the x squared minus 1 as a common factor, so divided x squared minus 1 from both top and bottom. Each term divided by x squared minus 1. Then after that, we simplify further. So we expand. Negative 2x cubed plus 2x. This times 4x cubed plus 4x all over x squared minus 1 cubed. Then continue collect the like terms. We have 2x cubed plus 6x over x squared minus 1 cubed. Then factor the numerator. Common factor is 2x. Each term divided by that is x squared plus 3 over x squared minus 1 then cubed. Then f double prime equals 0 means the numerator equals 0. Solve it. You will see 2x equals 0 or x squared plus 3 equals 0. Move it to other side. X squared equals negative 3. No solution. No real solution. You could have imaginary solution. So this one bring the 2 to other side, do the opposite operation, so you have x equals 0. Then the denominator, we are going to see undefined will be denominator equals 0. So x squared minus 1 cubed equals 0. Do the third root for both sides. We have x squared minus 1 equals 0. We have x squared equals 1. Then square root both sides. We have negative 1 and positive 1. We know these are the vertical asymptotes. It's restrictions for the domain, so no point of inflection at this point. Okay, this x negative 1, positive 1, not point of inflection. So we are going to check the sign of the f double prime. And when you check the sign for double prime, be careful, even if you don't have the point of inflection at these 2 zeros for the denominator, you have to include all the zeros. The reason is the zeros for numerator and the denominator will change the sign of the f double prime. So we have to include all zeros, even if they are not point of inflection. So it's true for the function and f single prime when you are checking the sign. So now we have 3 zeros. So this is x-axis. We have x equals negative 1. We have x equals 0. We also have x equals 1. So these 3 zeros divided the x-axis into 1, 2, 3, 4, 4 intervals. So this is x less than negative 2, between negative 1 and 0, between 0 and 1, greater than 1. And f double prime, we want to put the factors here. So 2x times x plus 3x squared plus 3, and this one is x squared minus 1, then cubed. Okay, then after we have these 3 factors, we are going to see the negative positive sign make the f double prime negative or positive. So negative 2, we can pick a number, negative 3, sub in, negative, sub in, positive, sub in. Negative 3 squared is 9. 9 minus 1 positive, cubed is positive. So f double prime at this interval is negative. Between this one, we pick negative 0.5. So sub in negative, negative 0.5 squared is positive. Negative 0.5 squared will be less than 1. Minus 1 is negative. Negative 1 cubed is negative. So 3 times together or divide give you if even number of negative give you positive. So this one we pick 0.5, positive number is positive. 0.5 sub in positive. 0.5 squared less than 1 is negative. So the whole thing is negative. X greater than 1, positive. We pick a number 2, sub in positive, positive. 2 squared is 4, 4 minus 1 is positive. 3 cubed is positive, so positive. And we know that this is vertical asymptotes, this is vertical asymptotes. They are not the point of inflection, but x equals 0, the sign changed. So this is point of inflection. Okay. Inflection. So now we come back to use the information that we have to do the graph. So we have the xy intercept, we have the vertical asymptotes, horizontal asymptotes, and we don't have critical points, which means we don't have the maximum minimum, and we don't have the Then we have the point of inflection. Okay, so now we come back, and there's no maximum minimum, so we don't need to worry about the y scales. It just go by 1 is okay. So this is x, this is y, and -1, +1, we have these scales. Then y, x equals -1 is our vertical asymptotes. X equals +1 is another asymptotes, vertical asymptotes. And also we have horizontal asymptotes because the degrees of the numerator is less than the degree of denominator. Then 0, 0 is our zeros. And after that, on the x less than -1 is negative, so it means it's concave down. And this concave up, concave down, concave up. So less than 1 is concave down. So we are not able to graph this way because we don't have the maximum minimum. So concave down, only way we can do is this way. And this x greater than 1 is concave up. Concave up. If we draw this way, it will be concave up. Okay. And also you can use a point, just put x equals 3. Here you will see it's positive, so the graph is positive. If you put a negative number, -3 here, you will see the function is negative, so it should be below. Okay, concave up, concave down. And x less than negative, between 0 and -1 is up. Is this way. So concave up. And also you can put a number to the function f at x. So 0.5 put here, you will see -0.5 is negative, here is negative, becomes positive. So the graph is positive and is concave up. Let's open this direction. And this is concave down, so it's change this direction. And also you can put a number 0.5 to the function f at x, you will find out it's negative. Okay, so this is a graph. We don't have the maximum minimum, so we don't need to sub in x value, find where is a local maximum, local minimum. So from this graph, we have horizontal asymptotes, vertical asymptotes, we have 0, and the x-intercept, y-intercept, same thing, and also this is a point of inflection. So this is a graph for this one. So you need to find the numerator equals 0, denominator equals 0. And for the denominator equals 0, for the f double prime, even if it's undefined, we still need to use those all zeros to draw this chart to find the sign, positive or negative. So this is a curve sketching for the rational function. And after that, we are going to see 2 more examples. That is based on the given information to do the graph. The function's expression isn't given. So example 2. Sketch a graph of a function that satisfies each of the conditions. So question A is one function altogether. So f double prime is greater than 0 when x is less than -1. So we could draw the x-axis, and on that one, -1, the f double prime is negative, so it's open down. And greater than -1 is positive. Sorry, this one is positive, and that one is negative. Okay. And also f prime at -1 equals 1, and f at -1 equals 2, so it means you have 1 point. So from all this one, we could just draw this x and y. We don't have the maximum minimum, so only 1 point, negative 1, 2. So we could go by 1. So negative 1, 2 is this point, and at this point the slope is positive 1. So here the graph must go this direction. And on the left is open up. So it will be something concave up. Then on the right side is concave down. Okay, so this is the point of inflection. So negative 1, 2, this side concave up, this side concave down. Then here the slope is positive 1. So just based on those information, we can just sketch this graph this way. And for the second one, f double prime is less than 0. So we have negative 1, positive 1. So we draw the x direction. So negative 2 and 1. Between negative 2 and 1 is negative, so open down. And less than this one is positive, open up. Greater than 1 is positive, is open up. Then these two are the points. So we are going to sketch this one. Negative 2, negative 4 is 1 point. 1, 2, 3, 1, 2, 3, negative 1. So please, when you do the curve sketching, label x and y axis and also label the scales. So negative 2, negative 4 is 1 point. And 0, 0 is another point. So at 1 is changing the, so 1 is changing the is point of inflection, and the negative 2 is point of inflection. So on the left is open up. So this is open up, is a point of inflection. So we are going to just do this one, then this will be open down until 1. Then from 1, it will open up again. So this is a point of intersection, inflection. So this is kind of the graph like this. So this is based on the given information, you just graph it. So this is a open down, open up. This is a open down, then open up. So next example is given information to find the expression of that function. And so we have ax cubed plus bx squared plus cx plus d. We don't know the a, b, c, d, but we have some information given. So have a point of inflection. It means f double 0 equals 0 or undefined. This is one equation. And the local maximum minimum, it means f prime at this x input equals 0. So we have these two, and also we have 2 points on the graph. So it means x equals 0, then f at 0 equals 2. This one, x equals 2, then f at 2 equals 6. So we have 4 information given. Then we have 4 unknown. So we have 4 equations to solve 4 unknown. It works. So first the thing we want to start with a point. So when x equals 0, f at 0 equals 2. We sub in the 0 to the function. We have 2 equals a times 0 cubed plus b times 0 squared plus c times 0, then plus d. This is our equation 1. And the equation 2, x equals 2, we have f at 2 equals 6. So 6, f at 2 is 6, a 2 cubed plus x equals 2. b, sub in the 2, plug in the 2. c times 2 plus d. This is equation 2. Then equation 3. So both of them involve f at x. So we are going to find f at x equals 3ax squared, degree to the front, degree minus 1, then plus 2bx, degree minus 1 is 1, then plus cx. 1 minus 1 is 0, so it's c. Constant is 0. So from f prime 2 equals 0, it means we sub in 2 here. 0 equals 3a 2 squared plus 2b times 2 plus c. This is equation 3. Then double prime. 2 bring to the front and then 2 minus 1. So 6ax plus 2b. c is constant. So f at 2 equals f at 0 equals 0. So we sub in 0 here is 0. 0 equals 6a times 0 plus b. So this is equation 4. We have 4 equations we want to solve for the a, b, c, d, and we want to start from the one that is easier to find. That is, this is 2b. From the last one, because 0 times 6a is 0, you have one variable left. So from equation 4, we have 0 equals 2b, then give us b equals 0, okay? And after that, we want to start from the first equation, from equation 1. 0, 0, 0 times anything give you 0. So from equation 1, 2 equals d. So we get rid of 2 variables from 2 and 3. So we sub 0 and sub b equals 0, d equals 2 into equation 2 and 3. So we are going to have 6 equals 8a plus b, 0 is gone, plus 2c plus 2. This is a new equation we call 5. Equation 3, we sub in 0 equals 4 times 3 is 12, plus 4b is 0, plus c. So this is equation 6. From these 2 equations, we could use elimination or substitution. So elimination will be change the number at front to be same. So we times 2 to each term in the equation 6. Okay, then subtract. So equation 5 minus 2 times equation 6. Then 6 minus 0 is 6. 8 minus 24. 2c minus 2t is 0 plus 2. Move the 2 to other side. Minus 2 is 4. 8a minus 24 give us negative 16a. Then move the negative 16 to other side. We have a equals negative lowest form 1 over 4. So we only have one variable left. It's c value. So we could use a sub a equals -1/4 into the E0 equation will be 6 to solve for C. So 0 equals 12. -1/4 times plus C. So this is a fraction multiplication, numerator times numerator, denominator times denominator. So 12 times -1 is -12 divided by 4 is -3 equals 0 plus, then move the 3 to other side, C equals 3. Therefore, we have A equals -1/4, B equals 0, C equals 3, and D equals 2. Then we have all those unknown variable found. So D equals 2. Therefore, the equation f at x, the function f at x equals -1/4 x cubed plus 0x squared is gone, plus 3x plus 2. This is our function you want to find. So the important thing is you have 4 variables, you need to have 4 equations given. So the points is, each point is one equation. So sub in x, y. This is x, this is y, this is x, this is y, sub in. Point of inflection at that point means 0 or undefined. So this is polynomial function. We don't have undefined, but we do have double prime equals 0 at point of inflection. And local maximum, minimum is a slope equals 0. So this is a answer for this question. Okay, so today's lesson is graph, a rational function, and we find x, y intercept, we find the horizontal, vertical, oblique asymptotes, and we found the critical points when f prime equals 0 or undefined, the point of inflection only if double prime equals 0 or undefined, and also change the sign. Otherwise, it's local maximum or minimum. So when we graph the chart for f double prime, make sure you need to consider zeros from both numerator and denominator. Even if it's a whole, you still need to use it in this chart, okay? So the whole, maybe you don't have to use it, but if it's a squared whole, then it changes the sign. So it's better to use all the zeros, then check the positive or negative. And when you do the graph, you could find the zeros, find the vertical asymptotes, horizontal asymptotes, and based on the concave up, concave down to determine where the graph will be. And if you don't know it's about the horizontal asymptote or not, you can sub in a number. Just sub in a number that is on the left of this vertical asymptote to see it's above or below. Then it's easier for you to graph. So, and also from given information to find the how to graph the chart. So based on the point of inflection, then from here it is concave up, concave down is changing. Okay, thanks for watching. And sorry this lesson is a little bit long.